1, 2, 3, 1, 2, 3. Assalamu alaikum wa rahmatullahi wa barakatuhu. Here, this is a part of unit number 3. We want to learn about certain metallic elements. We want to learn about certain metallic elements, certain non-metallic elements, and certain metalloids also. So today I am going to discuss with you sodium. If you consider sodium, as you can see in the diagram, is a very silvery, shiny metal, sodium. Sodium, you know, it belongs to the group 1 of the periodic table. Group 1 of the periodic table. Group 1 metals are generally highly reactive. So sodium is not second to that. Sodium is a highly reactive element. Further, sodium is not a native metal. Okay, it is not existing in the form of sodium in the nature. It is because of its high reactivity. It exists only in the form of compounds. The most common sodium compound occurring in the world is sodium chloride. Okay, you can notice sodium chloride in the sea water. When you consider sodium, because it is high in reactivity, if it comes in contact with air, it can easily react with air and turn to sodium oxide like compounds. To this reason, sodium is stored in paraffin oil or kerosene. Sodium is stored in paraffin oil or kerosene. So if you take sodium, okay, storage, sodium storage, we are going to see sodium. Okay, if you take sodium in laboratory, you will see sodium is placed inside a liquid material. Here there is an oil there. The sodium is sinking in the oil, and that oil is generally paraffin oil. In the absence of paraffin oil, kerosene is also a choice. We should avoid sodium metal coming in contact with air. Okay, if you keep sodium out of the paraffin oil, it will start to react with the air. Then sodium's surface will be gradually becoming dull. Its shininess will go. Sodium is a softer metal. So using a normal kitchen knife, you can easily cut. You can easily cut mean that you can understand it's that much a softer metal. Okay, sodium will be quickly losing its luster. Your book says if you freshly cut, the cut surface will be shining silvery. It will be shining with silvery luster. Okay, it will be shining with silvery luster, but that luster, that shininess will not stay long. Quickly that luster will disappear. Okay, it will tarnish. Okay, now what are the physical properties of sodium metal? Sodium metal's one physical property is a soft metal. You can easily cut it with a knife. Sodium has a density 0.97 GCm-3. This density is less than that of water. So in water, sodium floats. All the metals can conduct electricity. So sodium metal also can conduct electricity. These are the physical properties. When you come to the chemical properties of sodium metal, sodium shows a high reactivity with oxygen. If you allow it to contact with air, quickly it will react with oxygen and form sodium oxide. When you put sodium in water, sodium will float on the water and will react in the water. It will be floating and reacting. I will show you a video that sodium reacting with water. Okay, so sodium, if you put in water, it will react in water. You can see this video. This is sodium in paraffin oil. Okay, sodium is in paraffin oil. You can see the oil there.
And look at sodium. Like the lithium, sodium is stored in mineral oil to minimize reaction with the oxygen in the air.
He is taking a piece of sodium out.
Metal. You notice that it's also put it over with an oxide.
He is cutting it with a knife. You know, it's a softer metal. It will be easily cut.
One metal becomes softer as you go down the column.
So when you cut and open, you can see now the inner surface, the cut place is very shiny.
As we cut off the oxide layer, you can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. Sodium.
It is conducting electricity. So the LED here is working. It is conducting electricity. Now he is adding sodium to water. You can see sodium is floating on the water and moving on the surface. When it is moving, it will create a sound. Its size will gradually decrease. It will become a spherical material. It will become a spherical material. Gradually, size will decrease. And finally, it will disappear. Okay. So, when sodium is reacting with water, hydrogen gas will be collected. Here, he is collecting the hydrogen gas. To see the hydrogen gas, when you bring it near to a candle flame, you will hear a popping sound. Okay, you will hear a popping sound there. Okay, so those are the ideas. We will later understand what is this pink color is. So this reaction with sodium metal is described to you by your examiner. Sodium metal vigorously reacts with cold water, forming sodium hydroxide. Here in the reaction, after it reacts, what is being here is sodium hydroxide. After sodium reacts, what is being here is sodium hydroxide. Sodium hydroxide is a base. Because it is a base, to find out it, we are adding some phenolphthalein. addition of phenolphthalein is making it the pink color. Pink color says it is a base there. Sodium hydroxide is a base. Okay, so what can you understand here is sodium metal is vigorously, fastly reacting with cold water, and what is produced? Sodium hydroxide is produced. What else is produced? Hydrogen gas is produced. Further, sodium, if you allow it to react with, acid, we should not try it. In my life, I have tried once in a class. It really worked, but thing it is very dangerous. Okay, sodium reacting with acid. Here, he is taking some hydrochloric acid, and putting a piece of sodium into it. When he put the sodium into it, you see, that is a piece of sodium he is adding. He will add it now. Added. So it is very vigorously reacting, violently reacting. You see, it will catch fire. It will catch fire. Wait and see, it will catch fire. It will blast, it will spark. Hope you can see it is catching fire. Okay, so this way, this kind of reaction, your book is describing by the word, it is a violent reaction. Here in this reaction, okay, we are using diluted acids, and there are two products coming here. One, it is salt is formed, and other one is hydrogen gas is formed. And the book is telling, please don't use sodium plus acid reaction in the classes. It is very, very dangerous. Okay. Finally, what are the uses of sodium? In sodium, this is one of the compound called sodium cyanide. This sodium cyanide, okay, is used in extraction of gold and silver. Sodium compound called sodium cyanide is used in the extraction of gold and silver. Another one, sodium amalgam. It is sodium plus mercury together. It is used as a reducing agent in organic chemistry. Once you go to the advanced level and study science as a stream, there's a chemistry subject there. There you will study sodium amalgam, zinc amalgam, like many amalgams you will study. It is a reducing agent. Another one, it is also useful in the extraction of titanium, zirconium like metals. It is also important in the production of indigo dye, which is used to give a blue color to denim clothes. And finally, it is used as a street, okay, it's a vapor, sodium vapor is used in street lamps. If you see street lamps are working in yellow color, then they are belonging to sodium vapor lamps. Okay, so this is the total chemistry of sodium you have been given, right? I will be giving you a short question paper. You children write the answers, okay, and wait for my scheme. Inshallah, I will be discussing chemistry of magnesium in the next video, probably on Monday. Jazakallah khair. Assalamu alaikum wa rahmatullahi wa barakatuh.